Hello, this is Mr. Pruitt. This is a video on power. This is part 3 of a series of work, energy, and power. Alright, so a little bit of review. Remember that work is the means by which energy is transferred. In the picture to the right, we see energy being transferred from the man to the lawnmower as he's pushing it. We also can define this as the product of the net force and the distance over which the force is applied, which gives us an equation of work is equal to Fd, or work is equal to mass times acceleration times the distance. Now, power is the rate at which work is done, and the easiest way to think of power is it's basically a speed. It's how quickly the work can be accomplished, or how quickly it can be done. Most people, when they watch commercials on TV or something like that, and they hear about them talking about the amount of power that the engine that this truck has, or something like this, they think of it as a measure of how likely something's able to do work. But in reality, it's just a measure of how much work gets done in a certain amount of time. It's really more about how fast the work can get done. And thinking about that, it's really important to remember that if you can assume that two things both can do the required amount of work, then the more powerful thing is just able to do that work faster. So to give you an example of that, let's assume that you have a boat and a trailer that have a combined mass of 300 kilograms. And you're going to the lake this weekend. You have two vehicles that are both capable of pulling the boat. You have a 4-cylinder Kia Sportage, and you have an 8-cylinder Ford F-150. During your trip, you're going to be climbing 4,000 feet to a higher elevation, and you want to get to the lake as quickly as possible. So which of these two vehicles should you take to get to the lake most quickly? Well, since both of them can pull the boat, you don't actually have to worry about whether or not one of them is actually going to get there or not. The Kia is just as likely as the Ford to get you to the lake. The problem is that you want to get there fast, so you want to get the more powerful engine to pull the boat faster as you're going up the road against the elevation. So in that case, you'd probably pick the F-150 because it has a more powerful engine. It is capable of doing the work at a faster rate than the Kia is. So how do we calculate power? Well, power is calculated with the formula power is equal to work over time. Or if we wanted to expand that, we would say that power is equal to force times distance over time. The unit of power is what we call a watt. It's the same unit that we see on light bulbs. It's when we talk about things about light bulbs, and we talk about how powerful they are, it just tells us how bright they get, right? And ones that are more powerful, that have more watts, get brighter. Now, you do need to think about this. Since the unit of power is the watt, and that's a capital W, you don't want to get the unit confused with the W in the formula for power. The W in the formula stands for the work, not for the watts. Alright, so as an example of how we use this formula, let's say that we have an Olympic weightlifter, and he raises a 1,570 Newton weight a distance of 2.2 meters, so basically from the floor to over his head with his arms fully extended. And it takes him 0.8 of a second to do that. We want to know what his power output is. So we go to our formula. Power is equal to force times distance times time. So it's 1,570 times 2.2 divided by the time it took, which was 0.8 seconds. And if we use a calculator, we come up with a work output of 4,317.5 watts. I hope this was helpful for you, and there will be an assignment over this tomorrow. Thank you, and have a good night.